I want to fill in these last 2 pages from your notes together because I want to emphasize a few things. So let's start. It says the graph function f of x equal ax squared plus bx plus c can be written as y equal f of x. Let's write it after you complete the square. If you remember, it's going to be of the form a x minus h squared plus k, of course with a not equal to 0, where the graph, where h is, remember that is the x coordinates of your vertex. This is negative b over 2a, and k equal the value of the function at that point, and this will be the x and y of your vertex. Now the graph of f has the following characteristics. First of all, it is a parabola with vertex hk, and the vertical line, be careful please with the vertical line. You have to have x equal to h. It's not h by itself. It's not a number. It's an equation of a line. I will take off in the test if I don't see x equal to h. It opens, let's see, what are we going to write here when it says if a is greater than 0, that means it opens up. And of course if a is less than 0, that means it opens down. It is, let's see, what are we going to put here? Compared to then the graph of y equal to x squared if the absolute value of a is less than 1. That means the coefficient is a fraction. Remember from graphing techniques, that was the shrinking, and a parabola, when a parabola shrinks, it becomes wider. And if absolute value of a is greater than 1, it's going to be a narrower parabola. Now the y-intercept is, this is very interesting, and it's going to be something that's going to affect the whole chapter for other polynomials later on. Let's look. Y-intercepts occur when x is 0. Let's look at the original function. When x is 0, this term is gone, this term is gone, and we're left with c. So guess what? This constant in a polynomial function always gives you the y-intercept. So it's a very important fact. For the x-intercepts occurs when y is 0. Now y is f of x, right? Y is f of x. So we need to set the function equal to 0. So the x-intercepts are found by solving the equation ax squared plus bx plus c equal to 0. We already know how to solve a quadratic equation. Do you remember? Let's look at the quadratic formula. We know that it is solved by x equal negative b plus or minus the square root of b squared minus 4ac all over 2a. So now it turns out to be that things are going to be depending on this quantity b squared minus 4ac, which is under the square root. So depending on that, here's what we're going to have. Let's think together. If this quantity is greater than 0, right, then we're going to have a square root of a positive number, so there will be a number here. So we're going to have two x-intercepts. One of them is negative b plus that quantity over 2a, and the other one is negative b minus that quantity over 2a. So see the x-intercepts, there's an s, r, there's two of them, negative b plus or minus the square root of b squared minus 4ac all over 2a. So again, there will be two x-intercepts. Now, what happens if this quantity, we call this the discriminant. You don't have to worry about the name, but that's what it is. It's the discriminant, b squared minus 4ac. If that quantity is 0, what happens, guys? This is gone. This is gone. So what are you ending up with? Negative b over 2a. So look at this. The x-intercept, there's no s because there's only one x-intercept. Again, this is 0. This is gone. So all we have is negative b over 2a. But I want to discuss this situation. How can you have a parabola that intersect the x-axis in only one point? Well, that point has to be the vertex, right? That's the only way. Look, these are all the situations. The vertex has to be your x-intercept. Wait a minute. Isn't it that negative b over 2a is the vertex? The x coordinates of the vertex? Isn't that amazing? Do you see the relationship? Yes. So we will have only one x-intercept if b squared minus 4ac is equal to 0. Now what happens if this quantity is less than 0? Well, we cannot take the square root of a negative number in real numbers. So there are no x-intercepts. Okay. Now, let's look at these two examples. You'll see something like that in your tests. So let's look at the first. It is going to be multiple choice too. Here's the situation. For this function, I have a is less than 0. We already know what that means. When a is less than 0, right? It opens down. And the discriminant equal to 1. We just, again, so let me bring that back. So a is less than 0, is right there, opens down. And the discriminant is equal to 0, so there's only one x-intercept. So can you choose one of these three? Which one that has a parabola opening down and intersect the x-axis is in only one point? That's the only one, B. Let's look at the other one. Okay. For this function, a is greater than 0. That means it opens up. And the discriminant is greater than 0. And what does that mean? That means we have two x-intercepts. Which one of these situations that opens up and we have two x-intercepts? Yep, it is A. Okay, now you can do the homework.